So we have given string array of size n, and the length of each string in that array is of length n, and the string is a binary string, which means each character can either be 1 or 0, nothing else. So it's a binary, it's an array of binary strings. We have to return a new string which is also of length n, but it is not present in the given array of binary strings. For example, you are given for example, let's n equals to 3, and for n equals to 3 you will have an array whose size is 3. That means in this array I have 3 strings, and all these 3 strings will have the length 3. So for example, let's say one string is 0 0 0, another string is 0 0 1, and third string can be 0 1 0. So there are other possible strings. So for n equal to 3, we know that total number of possible binary string will be what? 2 raised to power 3, which means 8, because at each index we have two choices, either 0 is present or 1 is present. So for 2 times 2 times 2, total number of such strings possible are 2 raised to power 3, or in general for n length of string we can have total 2 raised to power n possible strings, and obviously this 2 raised to power n is greater than n. So our given array is not covering every possible string. It is having a subset of those strings, and we have to return any such string which is not a part of that subset. There are many other. So for if I go to for n is equal to 3, 3 are covered here and 5 are yet to be appeared. So out of those 5 left strings, I can report any string as my answer. So for example, 0 1 1 is one such string. It is not present in this array and it can be my answer, and I'd return it. So what is the very straightforward solution to this problem? It is that let's generate all strings, all possible strings. In worst case, how many at max how much strings we will generate if we do this? So for that, let's see the constraint given in the problem. If you see, you have the constraint on n is 1 to 16. That means at max n can be 16. N can't go beyond 16. So at max, in the worst scenario, we will generate 2 raised to power 16 strings, And what is the value of 2 raised to power 16? It is 65536. So somewhere around 10 raised to power 4. 6 into 10 raised to power 4, somewhere around 10 raised to power 4. Okay. Now once I generate all possible string, one by one I pick up each string and check, is that string present in my given set of string. So for that I have to iterate in all possible strings, and look for that string either present in my uh, given subset or not. If I put all these strings in a set, then lookup time is big of 1. If I put all of my given strings, if I include all of these strings in a set, let's say unordered set in C++, then lookup time is big of 1. In big of 1, in a constant time, we can look whether a particular string is present or not. So what will be the time complexity of iterating in all the strings and checking if that string is available in my given set is present or not, is 10 raised to power 4 times constant time. So it is still around 10 raised to power 5 worst time. So this approach can be followed because it is not going beyond 10 raised to power 9, which is our limit which we should not exceed. So let's do it. First of all, we will generate all possible strings of length n, and this n is num stored size. Now how to generate all possible strings? For that I'll write a different function, and let's just type is void, and I'll name it generate strs. Okay, so let's think of their arguments later, but this generate str will generate all possible strings one by one. So let's initially we have nothing. Initially we have an empty, we'll start with an empty string, right? And we have index from 0 till n minus 1. In an n bit string we have index from 0 till n minus 1. I'll start with an empty string and I go to I index is equal to 0. For that index I have two choices, whether I place a 0 here or I can place a 1 here. So what I'll do, I will create two cases. In case 1, put 0 at, let's say we are at any general index I. idx is equal to I. In that case, put 0 at index equal to I and get all the strings, and get all such strings which have 0 at index I. Get all strings recursively, get all the strings. So put 0 at this index I and recursively do to get all such strings which have 0 at index I. And similarly, in case 2, I'll put 1 at this index idx is equal to I, and I'll generate rest strings, rest part of the string, which have one at index I. So all the strings which have at index 0 and at index 1, I will put them in one single data structure. That can be a vector, or that can be a set also. So let's do it. So let's say at any intermediary state, string current will hold the string that we have built so far. So initially when we call this function inside our this main function, so we'll call generate str on empty string. Initially current is empty, then one by one we'll make choices and we build the current. And we will also need n as a parameter to know where to stop, because n will tell us that at index n, if your index value become n, then stop, don't go further. This is my base condition, and return all the recursive calls from there. And current index I will store in a variable int idx. So we are at index idx. At index idx we have two choices: include 0, or second choice is include 1. So let's say in first case I'll include, this is my case 1, I'll include 0. So what I'll do, in current I will add 0. This n will remain same, and since I have processed this current index, so I will move to next index, that is in idx plus 1. In the case 2, n will remain same, which will tell us where to stop. I have to move to new index, but before that I'll append 1 to my current string. So at each index we will make two choices: include 0, include 1, and we will keep on making recursive calls. At the moment when idx becomes equal to n, then we hit the limit. We don't want more characters to be appended there. We got the string of length n in my current string. At that point, this current will have a string of will have one possible string of length n, and I want to store it somewhere. So let's say I'll create a vector, a global vector, to store those strings. So this let's name it possible strings, possible strs. So these possible strs will hold those strings. So once I got my current, I'll go to possible strs and I push my current in that, and after that I'll return. I don't want to make any further recursive call from there. So generate str will be called for value n. Initially we are at index 0, and initially we have the empty string. So when I call generate str's function, it will generate all possible strings of length n and store them in this variable possible strs. Once the work is done, now we have now we will iterate in this array and one by one check, is this one possible string is present in my given array nums or not. So to make this check operation or this lookup operation to take constant time, what I'll do, I'll prepare a set, because in set lookup time is big of 1. So I'll prepare a set of unordered set of string, let's say nums set, and in that set I will insert this nums. So it's nums dot begin nums dot. This way I'll initialize my num set with this vector of num strings. Now what I'll do, I'll iterate through strings in my possible str. So I'll use for each loop here. So for string str, for each string str in my possible str, so this for each loop will unroll my possible string possible str vector, and in the possible str we have strings. So for each such string str in my possible str, what I'll do, I'll check if this str is present in my nums set or not. So if nums set dot find is having str, and how can I do that? When we'll get this equal to nums set dot end. If I get nums, if it gives me a iterator which points to the end of my set, then which means this string str is not present in the given num set. So this is my answer. So just return str. Let's run it and see how it goes. I got an error, so I missed a semicolon here. One more error. For string str in possible, so it's possible strs. So it must be saying that we are not returning anything after for loop, although it will not be required. But let's say if every such string is present in my given set, then we don't have to return anything. So return an empty string there. So it's accepted, and if I submit it, so it got passed. One more small optimization which we can do it, instead of generating all the strs and after that checking each str in my possible strings, I can do this check condition at the time of my building, at the time where I'm building each possible string. So I can place my check condition here in this check condition directly here in this if block. So by doing that, I will once I got a single string which is not present in my given num set, I will not generate further any string. I will not generate more string. So by doing that we can escape many iterations. For example, here if we have this n is equal to 3, then instead of generating all 8 uh, strings, just generate this one, this one, this one, and if we are lucky, we'll get at n equal to 4. If the fourth string will be not present in the string, and we'll just return that. So that will just take n plus 1 iterations at max, and not the 2 raised to power n iterations. So we can do that also.